Hello my friend, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting math question: k squared minus k cubed equal to 36. We need to solve this equation for k, so right now you can easily pause the video and write a solution in the comments below, and then we will check our answer, so it will be really interesting. So first of all, let's write the 36 on the left side. So this is our first step. As a result, what do we have? We have the same beginning, k squared minus k cubed minus 36 and equal to 0. Really great. Right now, this 36, I suggest you to write, so this 36, of course, there are a lot of ways how can we express this, of course, maybe like 20 plus 16, 18 plus 18, but the best way to express this is 27 plus 9. In terms of our question, of course, yeah, a lot of ways. The best way, we can express this as 27 plus 9. And right now, let's do this. Let's express this 36 as 27 plus 9. So what do we have as a result? We have k squared minus k cubed minus 27 plus 9, yeah? So we have 27 plus 9. And in the end, let's open our parentheses. So let's write it with let's write it without parentheses. So we have k squared minus k cubed minus 27 and minus 9 equal to 0. And a lot of students might be asking, why do we choose 27 and 9? Why don't like 18, 18, 20, and 16? Because right here we have square and cube, and 27, it's really great expression because we can write it as 3 cube, and 9 is also really great expression. So we can write it as 3. You can write it as 3 square. And right now let's do it. So we have the same beginning, k squared minus k cubed minus 27, we have 3 cube, and minus 9, we have 3 square equal to 0. And right now, let's look at this question from a different angle. Why do we write these cubes and squares? Because we can group it. We have k squared, we can easily group it with this 3 square. We have k cubed, we can easily group it with this 3 cube. So right now, let's do it. Let's group it with parentheses, yeah? So the first thing, we're going to group our squares. So we have k squared minus 3 square, we have minus k cube plus 3 cube, k cube plus 3 cube plus 3 cube equal to 0. Really great. And right now let's look at this question from a different angle. We have two parentheses, yeah? And I really hope you understand my solution until this moment. This is not the hard steps, but with few tricks. So I really hope you understand it. What are we going to do next? Right now, what do we have right here? Difference of squares. Sounds familiar, yeah? We know this formula from school. This one, sum of cubes. So let's remember this formula. So first of all, difference of squares. So we have a squared minus b squared equal to a minus b, and times a plus b. Really great. And right now, a sum of two cubes. So we have a cube plus b cube. Maybe a little bit different formula. So we have a plus b, and times these parentheses. So a squared minus ab and plus b squared. Okay, really great. Right now, let's apply it. So right here, difference of squares. Right here, we apply a sum of two cubes. So let's start with difference of squares. So k minus 3, k plus 3. First formula, k plus 3. Second thing, we have minus. Right here, we have sum of two cubes. So we have k plus 3, and in other parentheses, k squared minus 3k and plus 9 equal to 0. Really great. And right now, what can we see? We can see the common expression k plus 3 and k plus 3 right here. So we can actually factor this k plus 3 as a common expression. So let's do it right now. So we have k plus 3. And in other parentheses, what we have? K minus 3 from here, so k minus 3, minus, right here we can write this one. So k squared minus 3k and plus 9 equal to 0. So I really hope you understand it. What we're going to do next? Right now, we want to simplify the second parenthesis. We can actually get rid of this parenthesis. We can actually get rid of this one. And then we're going to change all the signs to the opposite one because we have a minus, yeah? So we have k plus 3 right here. And in another parenthesis, we can actually get rid of this parenthesis. So we have k minus 3 minus k squared plus 3k and minus 9 plus 3k and minus 9 equal to 0. Right now let's change an order. We can reorder these variables, because it looks like this is a quadratic equation. We can write this minus k squared on the first position. So we have k plus 3 minus k squared on the first position. The next thing, k plus 3k, so plus 4k, 4k, and minus 3 minus 9, we have minus 12 equal to 0. And right now we can easily say, okay, we factor our question, so we can easily solve it. We can easily try to solve it, because we have a product of two parentheses, and the product of two parentheses equal to 0 when the first parenthesis is equal to 0, so k plus 3 is equal to 0, or the second parenthesis is equal to 0. In our case, we have minus k squared plus 4k and minus 12 equal to 0. So we have two equations. This one is linear equation. We can easily solve this instantly, because k first equal to minus 3. This is our first root, k first equal to minus 3. What about second equation? My quick recommendation is to multiply it by minus 1, because then we have like a classic order of signs. So for positive right here, k squared minus 4k and plus 12 equal to 0. So let's solve it. First of all, we have our first real number root, and secondly, let's find real quick our discriminant, or doesn't matter, this is also up to you. I prefer a classic method of coefficients, so maybe a lot of students here, so I just want to show you this basic method, a classic method. So from here, a equal to 1, b equal to minus 4, and c equal to 12. So let's find real quick, let's solve it for discriminant. So our d equal to b squared minus 4ac. So as a result, we have b squared, so minus 4 squared minus 4 times a times 1 and times c times 12. As a result, what do we have? Minus 4, we have 16, yeah, 16 minus 48. So our discriminant is equal to minus 32. So our discriminant is less than 0. So right here at this branch, we don't have real number roots, but we have two complex roots. So let's solve it. Let's solve this second part, k second and k third. Let's find our two complex roots, k second and k third. Our all-known formula, minus b plus minus square root of discriminant and all over 2a. Really great, equal to, right now let's plug in each of these elements into this spot. We know about b, so in our case we have minus b, so minus 4, plus minus square root of discriminant, square root of minus 32, and all over 2 times a, 2 times 1. Okay, minus 4 equal to 4, so we have 4 plus minus square root of minus 32. We can write it as square root of 16 times 2 and times minus 1. The same thing. We have 32 minus, we have minus 32, so the same expression. But in this case, there's one really interesting and a great property, because when you have square root of a times b, you can write it as square root of a times square root of b. And that's why we can split it like square root of 16 times square root of 2 and times square root of minus 1. Okay, so let's continue. 1 second, please. Yeah, like that. It's a great position, so let's continue. We have 4 plus minus square root of 16 times square root of 2 and times square root of minus 1. All over we have 2. Square root of 16 equal to 4. From here, square root of minus 1. This is our imaginary unit. This is our I. So as a result, in our numerator, we have 4 plus minus 4i square root of 2 over 2. The next thing, we're going to divide 4 over 2 plus minus 4i square root of 2 over 2. So that's my quick recommendation, because the next thing, you can easily say where do you have real part and imaginary part, because 4 over 2 equal to 2 plus minus 2i square root of 2. And right here you have real part and imaginary part. Of course, it depends what do you need from here. If you can easily leave it like that, if it's necessary for you, you can write it in that way, like a real part and imaginary part. So I really hope you understand it. So let's write our final answer. Let's gather all the roots together. So we have our answer, k first equal to minus 3, and k second and third equal to this one. So 2 plus minus 2i square root of 2. So we have one real number root. We're going to check it right now, and second and third are our complex roots. So right now let's do it. Let's check real quick our k first equal to -3, for example. First of all, let's rewrite our equation. So we have k square minus k cube and equal to 36. Right now let's check real quick our k first equal to -3. So we have -3 square minus -3 cube equal to 36. And I hope everything is great, because -3 square equal to 9. So from here we have 9 minus, with this minus, because right here we still have negative sign because we have an odd power. So -3 times -3 times -3 equal to -27. With this minus we have +27 equal to 36. So our root is absolutely great for us, and we can easily say that we solved this question completely, because from a different perspective there's like a theorem which is called like a fundamental theorem of algebra, and according to that theorem, for example, we have a cubic equation, so it means that we should solve this question for 3 roots, and we have it. We have 3 roots. We have one real number root and two complex roots. Even right here we have a quadratic equation, so it means the highest power is 2, so we have 2 roots. Where do we have it? Right here. In linear function we have k to the power first, so it means 1 root. And it's extremely important thing when you're struggling with a different variation of a quadratic equation, when you're struggling with that. So every time if you have a quadratic equation, you just have to guess, you just have to find out how many roots you can get from here, because cubic equation 3 roots. If you solve it for 1 root, it means that you forget about 2 roots. And second thing I want to underline, if a lot of students solve this question by inspection, they might be thinking, okay, k first equal to -3, because it's not that hard to guess this root by inspection. But one really important moment, because when you solve this question by inspection, you forget about second part. And second part, this is our complex root. You can guess a root. Of course, if you don't have a time on your exam, you can say, okay, k equal to -3, and you can prove it if you have like 2 minutes left on your exam. But if you have time, it's absolutely incorrect, because you forget about the second branch, about these two complex root, which is also extremely important for you and for your teacher and for your mark when you solve this question completely. And on the third side, it's also really great for you to pause the video and try to understand this solution, because maybe you still have any question. This is not a hard question. Of course, with a few tricks like that, we group squares and cubes, but in general, this is not a hard question. And if you still have any question, write it in the comments below. And we have a really great community here, a lot of teachers, a lot of students, so everyone will help you 100%, and I really want to say thank you for it, that we create such a community, that you watch my videos. We have like more than 600 questions, so it's really great material. It's really great mathematical content for students, for teachers, of course, and I really want to say thank you for being here and for everything. Yeah, so thank you for your time. Have a great day. Take care of yourself. Also write your thoughts, write your response. It's also really kind of you when you leave your honest response, of course. In a different sites, it depends on the question, but in general, I want to say thank you for everything, for watching this video, and for supporting my channel. So wish you all the best in your life. Take care of yourself. Have a great day. See you in the next videos.